Problems on surface charge distribution. First problem, a uniform sheet of charge with rho is 15 nanocoulomb per meter square is placed in xy plane. Then calculate the electric field intensity at point P on the z axis when P is located 4 meter above xy plane, and second is when P is located minus 4 meter below xy plane, and comment on the result. So first we consider the first case. So case first. So what is gear here? It is equal to 15 nanocoulomb per meter square. Nano means it is 10 raised to minus 9, and Z is equal to plus 4 meter. Now we have the formula for electric field intensity. So electric field intensity is given by E bar is equal to 2 epsilon 0 A Z bar. So it is 2 into 8.85 into 10 raised to minus 12 into A Z bar. So by solving this we get the answer 847.074 AZ bar volt per meter. Now second case. The second case here Z is equal to minus 4. So electric field intensity at this point is E bar is equal to rho S divided by 2 epsilon 0 minus AZ bar. So it is 15 into 10 raised to minus 9 divided by 2 into 8.85 into minus 12 into minus AZ bar. So the answer is minus 847.074 AZ bar volt per meter. Now we have to comment on these answers. So comment. So the first comment is here distance plus 4 and minus 4 is not used. So the magnitude of electric field intensity is independent of distance from the plane. And second is electric field is normal to the plane of charge. These are the two comments. The next problem is two infinite uniform sheets of charge of 20 microcoulomb per meter square are located at x is equal to plus minus 1 meter. So determine E bar in all the regions. So the two sheets of the charge we have to draw it. So solution, this one is the first sheet, and this is second. This is origin center. This is -1. This one is the +1. And this is this diagram shows two infinite sheets of charges. Which figure is this? Two infinite sheets of charges. So here both sheets give E bar that are directed along the x-axis. So we write here both sheets give E bar that are directed along x-axis. So we have the equation of electric field intensity. Equation of electric field intensity. So it is E bar is equal to rho s divided by 2 epsilon 0 A n bar. So what is rho s? It is 20 microcoulomb per meter square. So it is 20 into 10 raised to minus 9 coulomb per meter square. So now consider this is sheet 1. This is sheet 1 and this is sheet 2. It is located at x is equal to 1 meter and it gives the electric field intensity E2. So we write here, consider sheet 1 located at x is equal to 1 meter and it gives electric field intensity E1 bar. Similarly, consider sheet 2 this is at -1 and sheet 2 located at x is equal to 1 meter and it is denoted by and it gives intensity, electric field intensity as E2 bar. So total electric field intensity is ER bar is equal to E1 bar plus E2 bar. Now we know that we have discussed already that the electric field intensity is independent of the distance. So there are some simple rules to decide the direction. So the direction of A bar is always perpendicular to give the surface charge density. So in this case, x-axis is perpendicular to the given surface. If point P so there are three different regions, Now we write here the different regions. To consider point P, are first region is P is at LHS, that is left hand side, placed at x is equal to -1, that is x less than -1. The second condition, the second region is P is in between rho is 2. That is, it is x is in between x minus 1 and plus 1, and the third condition is P is at RHS of, that means x is greater than plus 1. So these are the three conditions. Now in every region, we write here, in every region both charge densities produces E bar. Both charge densities means E1 and E2. So first we calculate for case x is then minus 1. So E1 is equal to rho s 2 epsilon 0 minus ax bar. So it is 20 into 10 raised to minus 6 divided by 8.85 into 10 raised to minus 12 into minus ax bar. So its value is minus 1.13 into 10 raised to 6 ax bar volt per meter square. Now for this condition we have to calculate E2. So it is same to epsilon 0, it is minus x bar. So it is same, that is 1.13 into 10 raised to 6 ax bar per meter square. Now we have to find total. So E1 plus E2, it is minus 2.26 into 10 raised to 4 per meter square. Now second condition. So what is second condition for x is in between minus 1 and 1? So for that E1 is equal to epsilon 0 ax bar. So it is plus 1.13 into 10 raised to 6 ax bar square. Similarly we have to find E2. So it is 2 epsilon 0 minus ax bar. So it is minus 1.13 into, not minus, it will be, no, it is minus 1 into 10 raised to 6 ax bar volt per meter square. Now the third now total ER is equal to E1 plus E2 bar. So it get cancelled, answer is 0. Now the third condition for x greater than 1. So E1 bar is equal to 2 epsilon 0 plus ax bar. So it is 1.13 into 10 raised to plus 6 volt per meter square. And E2 bar is 2 epsilon 0 plus ax bar. So it is also 1.13 into 10 raised to 6 volt per meter square. Now what is the value of ER? It is E1 bar plus E2 bar. So it is equal to 2.26 into 10 raised to 6 ax bar volt per meter square. Now the next problem is a charge of uniform density S is equal to covers the plane to x minus 3y plus here is equal to 6 meter. Then find E bar on the side of plane containing origin. So what is given here? The plane is given. So the given plane is (2x minus 3y plus z is equal to c). So we have to draw this plane by calculating xyz coordinates. So we write here plane is drawn. The plane is drawn by calculating x, y and z coordinates. So x coordinate is 2x is equal to 6, so x is equal to 3. So it is 3, 0, 0. That is. Next, y coordinate minus 3y is equal to 6. So it is y is equal to minus 2, that is 0 minus 2, 0. And next is z coordinate. Z coordinate is, that is 0, 0, 6. Now I have to draw the plane. So this point is 0 minus 2, 0. This point is 0, 0, 6. This point is origin 0, 0, 0. And on x-axis it is 3, 0, 0. This is S. So this is the diagram for the plane 2x minus 3y plus z is equal to 6. Now here the given charge distribution is uniform shield. So we write here given charge distribution is uniform shield. So electric field intensity, so electric field intensity is given by E bar is equal to upon 2 epsilon 0 AN bar. So it is equal to 0.3 nano coulomb per meter square, that is 0.3 into 10 raised to minus 9 coulomb per meter square. This equation is 1. Now here what is rho is, it is what is AN bar? It is unit normal vector. It is unit normal vector. So the general equation of plane is ax plus by plus cz is equal to d. Now the unit normal vector, we write unit normal vector is given by, it is AN bar. So it is plus minus A x, it is ax bar plus bay bar plus caz bar divided by square root of a square plus b square plus c square. So the given equation is 2x minus 3y plus z is equal to 6. So we can compare it and we get a is equal to 2, b is equal to minus 3 and c is equal to what? It is 1. So therefore above equation will be an bar is equal to plus or minus 2ax bar minus 3ay bar plus az bar divided by square root of 2 square 4, 3 square 9, 1 square 1. So it will be plus minus sign common in bracket 2ax bar minus 3ay bar plus az bar divided by square root of 14. Now we have to calculate the E bar. So to calculate E bar on the side of the plane containing origin, along this side we have positive y-axis. So we write here we have to calculate E bar on side of plane containing origin. So along this side we have positive y-axis, we have positive y-axis, that is plus ay bar. So equation of an bar we should have plus ay bar direction. So to obtain plus ay bar, consider the negative sign of an bar. So to obtain plus ay bar direction, consider negative sign of an bar. So an bar is equal to minus 2ax bar plus 3ay bar minus az bar divided by square root of 14. Now put this value in equation 1. So E bar is equal to 0.3 into 10 raised to minus 9 divided by 2 into 8.85 into 10 raised to minus 12 minus 2ax bar plus 3ay bar minus az bar divided by square root of 14. So we solve this term and we get the answer 4.53 into bracket minus 2ax bar. We solve this much term minus plus 3ay bar minus az bar, multiply 4.53 into bracket. So we get minus 9.06 ax bar plus 13.59 ay bar minus 4.53 az bar volt per meter. This is electric field intensity. Next problem. A uniform surface charge density rho s is 2 microcoulomb per meter square in the region r less than 0.2 meter and z is equal to 0. And 0 elsewhere. So find E bar at P is equal to P having value r is equal to 0 and z is equal to 0.5 and second is P r is equal to 0 and z is equal to minus 0.5. So first we consider the first case. So given charge distribution is on circular disk. So we write here given charge distribution is on circular disk which is located at z is equal to 0 plane and radius 0.2, and we draw the diagram for this. So this is y, this one is x, this is z. So this is point P, this is dq having value r phi 0. This is vector r bar. Now we have to calculate E bar. So we write here calculate E bar at point P having values r is equal to 0 and z is equal to 0.5. So in cylindrical coordinate, system, coordinates of P are P0, 5.5. Now we consider, right here, we consider small point charge. We consider small point charge dq on given surface. That is, this is dq, small point charge on given surface. So it is in z plane, that is z is equal to 0 plane. So coordinates of dq are r, phi and 0 as z is equal to 0. Now we draw a vector. We already draw the vector from vector r bar from dq to point P. So it produces dE bar. So the general equation, we have the general equation as dE bar is equal to dq divided by 4 pi epsilon 0 r square a r bar. This is equation 1. Now here, what is dq? dq is equal to rho s, that is equal to ds. Now we have the calculations of equation of ds. So in cylindrical system, r is denoted by dr, phi is r d phi and z is dz. So the direction is given, structure is always perpendicular to it, hence the perpendicular direction is z axis. Therefore dq is equal to rho s r dr d phi. This is from cylindrical system. R is denoted by dr, phi is by r d phi and z is by dz. This is equation 2. Now here we have to find the value of r bar. So it is 0 minus r a r bar plus phi minus phi a phi bar plus 0.5 minus 0 a z bar. So we solve it and the answer minus r a r bar plus 0.5 a z bar. This is r bar. This is equation 3. And mod of r bar is square root of minus r square plus 0.5 square, so it is r square plus 0.25. This is equation 4. So we can write the unit vector as ar bar as so it is minus r bar plus 0.5 az bar divided by r square plus 0.25. So it is equation 5. Now we put equation 2, 3, 4, 5 in 1. We write here put equations 2, 3, 4, 5 in equation 1. So we get dE bar is equal to rho s r dr d phi divided by 4 pi epsilon 0 r square plus 0.25 here minus r a minus ar bar plus 0.5 az bar divided by square root of r square plus 0.25. Now we solve this equation and simplifying. By simplifying we get it is r dr d phi as it is 4 pi epsilon 0 and it is r square plus 0.25 3 by 2. We solve this bracket and this square root, so we get minus r bar plus 0.5 az bar. This is equation number 6. Now similar to the derivation of E bar due to the infinite point rays, due to the symmetry all AR bar component get cancelled. So we write here this sentence that now similar to derivation of E bar due to infinite row s due to the symmetry all AR bar components get cancelled. So dE bar is equal to rho s r dr d phi divided by 4 pi epsilon 0 r square plus 0.25 3 by 2. As all AR bar component get cancelled, only the 0.5 az bar is remaining here. Now what is given in the problem? Given is rho s is equal to minus 2 microcoulomb, that is 2 into micro means 10 raised to minus 6. So we substitute this value 2 into 10 raised to minus 6 into 0.5 r dr d phi az bar divided by 4 pi into 8.85 into 10 raised to minus 12, that is epsilon 0 into bracket r square plus 0.25 to 3 by 2. So by solving this part we get the answer minus 8.9877 into 10 raised to 3 r dr d phi az bar divided by r square plus 0.25 3 by 2. Now we have to calculate the E bar, so we integrate this equation. So we write here to calculate E bar, integrate dE bar. Now the variables of the integration are d phi and d phi. The variables of integration are dr and d phi. So here r varies from r is equal to 0 to 0.2 and phi varies from phi is equal to 0 to 2 pi. So the equation will be E bar is equal to minus 8.9877 into 10 raised to 3. This is constant, so it is outside the integration. Phi goes from 0 to 2 pi d phi and r goes from 0 to 0.2 0 to 0.2. Equation is r dr divided by r square plus 0.25 3 by 2. So we solve this integration separately. So here integration of 0 to 2 pi d phi is phi. So answer is 2 pi. Now r goes from 0 to 0.2 r dr r square plus 0.25 3 by 2. So we solve it and the answer is, so this integration is solved on the calculator, and to solve it manually we have to make the substitution for r square plus 0.25 as a t. So 2r dr is dt. The answer is 0.143. So it is solved on the calculator. Now the answer is E bar is equal to minus 8.9877 10 raised to 3 into this 2 pi into this 0.143 AZ bar. So it is 800 kilowatt per meter. Now the second part of the example is we have to calculate E bar at r is equal to 0 and z is equal to 0.5. Now we write here only z component is negative compared to first part of the problem. So E bar is negative of above answer. So the answer is E bar is equal to minus, this is already minus, so minus of minus is plus. It is 8.078 AZ bar kilowatt per meter. So this is the answer. As this is negative of negative is positive.